everyone, let's start our new project. Some of you may ask how to optimize a data. Our data sets up until now optimize really well. So how we can optimize a data? It's a good question. Because of that, I create a data set. Let me call it optimization project. This is a data set, a data CSV. We have 2 columns as output and 6 columns as input. And as you can see, this is a really annoying data set to deal with. Why it's so annoying? Because the numbers are really bullshit. It's the best way to say that. But let's go with that. The numbers are really crazily bad. And as you can see, we have lots of zeros. That means nothing. And also some of the parameters are the same. So how we can deal with this kind of data set? Okay, let's start to set a models. For this project, I'm not going to create any GitHub because just going to work on optimizations. But for that, I'm going to create a folder called model. Or let me create a folder in GitHub for that and just don't make it public, because I think it's not something worth of publications. Just because of that, let's go to GitHub. Let me just open our new repository. We call it optimizing project. Optimizing project with no description, and it also be private. Create repository. This is our repository. Now we need to do something. We need to open its desktop app, file, clone repository we need. Let's go with optimization. Where is that repository? Let's just search for that This is the one we want to clone. Let me just copy everything here, cut them down, go to this project. Okay, we have a little problem. It's not going to let us copy that. Now it's going to let us. Now I delete this thing and go here. And I also delete this thing. We didn't need that. Go to optimization project. We open our model. Create model 1. Folder for model 1. Let's start. Let's commit everything. Creating data. Just an easy thing to commit. And now in model 1, we need to create a new Python code. For that, we open our Anaconda. You see, the data we have, it's really bad because the data is so small, and after being small, we have another problem that the data is so unique that it's like nothing is going to set each other in that data. Because of that, we have a really hard work time, and our goal is going to be we get R2 or R squared more than, let's go 0.07. That's a good number, so let's start. At first, we are going to go to our project folder, desktop project, optimization project, model 1. Here we create a new notebook and we go to Gemini. Let me open our data. Okay, not paste as a picture. Control Shift V. These are the headers of our columns in the data set we have, and YC and YF are outputs and the other ones are input. I want to create a neural network model that can predict each of the outputs. I want to create a neural network for model for each of the output, separately, yes, each of the outputs separately. So can you write the Python code? I want to validate the model with R2 and MAE, and also give me the bisector chart and save the model, the bisector chart, and the and the scalar. Also don't forget to save metrics of 6 error and model detail in one CSV. We gave him a hell of the comment. Let's just wait for it to create that. Until it's creating, I'm going to do something. Okay, it's going to create it really easily. I'm going to copy all the data and paste it here by Ctrl Shift and V. Can you create a best? Can you say what is the best model to predict YC and YM, I think, YF from this data set using machine learning and neural network? We are going to do it both ways. Let me just copy that. We are going to our file, no kernel, select. We paste the data, but the thing you understand here is that the output columns, where it read the CSV file from, file prefix. Let's run it. I'm going to create a new folder and name it model 2. The problem about model 1 is that I didn't think anywhere I gave the directory of the model. So we just wait for that to tell me where we are running and change the directory of the model. Okay, it's going to run, I think. Let's see what Gemini is going to say here. It's going to give a good result. We're going to read all of that. Okay, what is it modeling for? You don't have the inputs. Where did you get the inputs from? I didn't get it. Create mock data. Oh, it creates its data by yourself. Okay, let's go take a look at the folder to see the inputs are right. Okay, the thing is right. Let's change it. I want to create a grade change. The CSV file with the data has the name. Let's see what is the name of the CSV file. Data CSV, data.csv. Oh, okay, it's good. It's going to change it. It's not going to create the thing it created last time. Let's take a look at the top of that. Okay, it's data calculations. Let's go to the down. That's I'm moving for regression model that remove the mock data generation, data.csv. Okay, let me just copy content, go here and paste it and try to read that. We need to find where the data is, where he added the data. It's not really that hard, but I don't know why I can't find that. Dev train. Okay, data.csv. We need to go back 2 times. Let's start going back. I think this way we go back. Another back. Data.csv. Now let's run it. Now let's execute the code. Let's now go to the Gemini and read it. Okay, let's read that. This is a great question. The provided data is small and the number of input features is moderate. The task is to predict 2 output variables. This is multi-operator regression problems. Given a small structure, here is answer of the best. The challenge, the biggest constant small problem of data point is immensely limited the complexity of the model. Okay. Deep learning, DNS, deep neural networks, complex ones are often data hungry. Training only is likely to lead to overfitting where the model memorizes the training data but fails to generate new and see data. Best machine learning for small models. Random forest, gradient both, supervector, and multilinear. Okay. A neural network, while a deep neural network is like the overflow, a simple shallow network could be a still valuable option. Okay, recommended model is the best model can be drawn through experimenting. Data pre-processing, splitting data, establishing baseline. Train a neural network, hyperparameters tuning. Okay. Let's start to get a code from that. It's a good concentration. Now, I want you to write the code for machine learning's models at models at first and save the bisector chart and the model and the metrics bisector chart as SVG and the models and metrics in the one CSV file. And also, okay, it's good. Let it write it. Let's go see the result. The R2 is really bad, as you see. The MAP is good, but the R2 is absolutely bullshit, and I can't even love that. R2-1, it's a really bad problem. I want to ask for you to show that something. Let me at first. Can you add the predicted with real number charts numbers data in CSV. Okay, let me just copy that. That's amazing. He created data by herself. I'm going to use that. Let's go create a new folder, name it model 3, and machine learning. Okay, let's new notebook. Let me execute this code. Machine learning. We are going to wait for the charts to be created. Okay. True value, random forest prediction. Okay. You see, we have a lot of problems here, that some numbers are good and some numbers are not good. Let me take a greater look at that. Model metrics. Okay, I didn't understand anything about these metrics. I want to change them. I want you to give me 6 error in metrics, and I want to have at least 3 non-dimensional, and I also want all the bisector charts with minus and plus 20% lines. Okay, let's go there and copy that. I hope it fixed the problem. Model 1. Let's execute that. Oh, we have a problem here. We have a problem here. The model name is not changed. We need to change the address. For that, I need to delete this thing. 1, 2, data.csv. Now run it. Okay, the times that the code crash, it's not important. We are going to run it again. Let's wait for the model to run. You see, this is running. Let me cancel that and run this model. Okay, it's running. Let's go to our machine learning. Copy the content. Paste it here. Run it. Okay, the R2s are a real disaster. A real disaster, I say, not a... Okay, let's see the charts. It's MLP, it's good. Regressor is good. Okay, random forest with actual is good. XGBoost is good, actually. Okay, I want to copy the results. These are the results. Can you improve the results to at least have an R2 over 60? Okay, we just need to wait. for the R2s. Here we have our data. I didn't remember what I didn't give anything about that. Let's go to model 1. Let's see the result. The R2 is really low. We copy this thing. Control Shift V. Can you improve the model to get better results? And also the model, let me just copy something from here. I'm going to find the place of model file. It's somewhere here, I think. No, it's random forest. It's here. Build CSV place to this in code. Okay, let's wait for it to create it. Now we have another code, but the most important thing is that I'm going to save this result to have them. I'm going to create another neural network file, model 4 machine. Let's call it machine. The learning is useless. Let's paste run. We call it machine 2. Let's run it. It's starting. Is it running? You can see from here it's running. Let's go see model 1. I wanted predicted. Okay, output with predicted. Let's take a look. You see the actual is 705 and it predicts 6 is good. 4-1 it's bad. 9-9. 5-2 is bad. 5-4 is good. 6-6 is good. 4-4 is good. 6-2 is bad. 6-5 is good. Actually, we have some good numbers also along the bad ones. Let's take a look at another output also. 69, 39, 34. They are good numbers. Not too bad, but the metrics are bad. So we need to improve the metrics. For that, let's go take a look at the metrics again. The bisector chart also is looking good. Okay, let's go to model 2. I'm going to save model 1. Going to model 2. We copy this content. Let's copy this. Run it. The model is run. The R2s are a little better. A little. Let me ask you something. No, here, not here. Why the R2 are not improving? You see, we have this problem. This is the time when programming becomes really, really hard and everybody like to back off. Okay, let me paste it again, run it. Okay, we have problems. Let me just copy it, fix the error. That's very common and frustrating issues when dealing with real-world data. Okay, the R2 score are not improving and are formed likely due to extremely limited data size. Okay. The best CVR score confirmed this. The best correlation scores models were and training data using cross validation. They won't achieve it on the unseen data set. Okay, so aggressive train test, I will change the split to 80%. Okay, let's check the new data and see if it's going to improve or not. It changed it. We are going to say goodbye to machine 2 and go to model 3 and we are going to call it model 5 machine. Let's paste the notebook here. Call it machine as always. Machine. And run it. The model 2 error, let's see if it fixed it or not. Let me read the error. I think it's about... Okay, let's copy that, run it. I hope, oh, the data is loaded, so the problem is something else. The R2 is improved very well. We have one good R2 here. It's a really good R2. It's going to run also. Let's take a look at both of them. At first we are going to take a look at machine learning 5, I think. Yes. Regressor. This is completely useless. This is also useless. The random forest is doing well. This is going well. This is going well. Exposed is going well. I really like them, but I want the best option, so I'm going to improve it more. Let's call it model 6 machine. Let me give it the result. The results are pretty good. Can you improve them more? Okay, let's wait for it to improve them more. And this is the model, new model. Let's take a look at the model 2 at first. Model 3 is empty. Let's take a look at model 2. The bisector chart. Okay, let's see output result summary. Oh, we opened another one. Don't save. I really don't like to save it. Okay, let's open it. The R2 is very good increasing. This is the results and improved very well. Can you improve it even better? A little overfitting is approved. Okay, let's see what it's going to do this time. I'm really hungry to know what it's going to do. Let's save this. Come back to machine 6 is empty. Let's create a new file. We call it machine learning machine. Let's call it ML. It's better. And I really love the sound of that. We are going to close model 2 and go to model 3. Copy the model 3 from here. Copy content. Let's paste and run it. I'm going to name it model. I don't know which number is it. I'm going to name it just model for now. Okay, it's not even understanding that this is code. We need to wait a little time for that, I think. Yes, it's going to learn the code. The ML is done. The results are getting better and better. Thanks a lot, Gemini. The results are getting better. Can you even improve everything more and more? Okay, let's give it to him. I want to see the result. Let's go and take a look. The model is going to run. Let's go to machine learning 6. The random forest is good. The results are the same with a better taste. I really like them. Let's say to go and see the model. Before that, let me see the raw results here. I'm going to set this. Can you improve it even more? It's not good and I don't like it. Make your network bigger, the epochs higher, and also make your hidden layers more and learning rate less to get the exact results I want. Also use grid search. No, not grid. Also, what I want to ask him, there's a learning rate this and get the exact result I want. What I said, I don't like it. Make your network bigger, the epochs higher, and also make your hidden rate more and learning rate less to get the exact result I want. Okay, this is a good comment. I want to. I think I gave it the result. Can you also use grid search and for better results and make the epochs more and learning rate less? Okay, let's copy this to in new models. I'm going to create a new folder. Let's call it model 4. Model 4. Here, new notebook. And also I'm going to create machine learning 7. Model 7 machine. Let's open it. Let me call it model. So I didn't make them wrong from each other. Model. Okay, we are there. Let me copy the model. Run it. That's it. We call it machine. Let's create the code. Let's write it, name it machine. I want to see the differences. Let's go to the model and see the structure. It's getting deeper and deeper. It's a really dense model and deep model. It's going to work better, I think. And also, if it's reducing the epochs, I have a very Good hope for the results. It's using aggressive tuning. It's a good thing. Okay, the R2 are good in YF and the MAP is low in all of them. It's a very good result, very solid one. I like that. Let's take a look at another thing. The R2 improved, but this R2 is reduced. I want to just see if it has validation data or not. I'm going to see the train test split in the model. It's really important for me. Let's go for train test split. I hope it has white through white red. It's upper, I think. In the up, it's a definitions. There's not here. Create bisector chart, depth field model, depth train and save. Okay. Dev input train test split is here. Train test size is good. A stand scalar, everything is good. MAE. Okay, we are done. But there is something that you can change data by your hand to create the best possibility. That we are going to study that in the next video, and I'm going to give you a complete lesson on something that I think I created by myself. And I don't know if it is a real thing or not, but I like really changing data by myself and done this kind of work. I hope you enjoy it as I enjoyed a lot. I hope all of you have a nice time.